are literally shaping the planet.
Purpose is the only pathway to a regenerative future.
We have a choice to stay with the status quo or to change.
What is the point of trying to be just resilient when we can actually innovate?
My name's Barrett Clark. I really appreciate Shadow having me today. I come from a slightly different sector than most of the people presenting at this conference. My background's in robotics. So kind of on the right here, you see a visual representation of my path kind of over the last 10 years. I started out in legged locomotion, studying optimal control in walking robots, and then convinced some people in Atlanta that I knew something about computer vision. And over 6 years, I helped SoftWear Automation raise 2 rounds of funding and kind of have our first successful deployments of full stack robotic systems into the field. And then now I've been at Bright Machines for about 18 months, where we are really trying to innovate around what we call software-defined manufacturing, but filling in a lot of the gaps, both technologically and logistically, to make automation more flexible, to allow it to have a return on investment that's more useful for more people, and really to kind of disrupt this industrial automation space. So let's see. So today we're going to talk a little bit about automation. Like I said, from a slightly different space. So I'm going to talk about automation in broader brushstrokes, right? And hopefully, kind of draw the comparison of what other industries are doing and how I think this would be beneficial to the AEC space. So, setting context before we get started. What is automation? Well, automation is really anything that helps remove the non-cognitive and routine work out of a particular task. So humans are really good at these cognitive and non-routine things, and automation is super helpful to replace things that aren't that, right? So a lot of people, when you hear the word automation, maybe you think about a robot. Well, in my mind, a robot is a subset of automation, but it's not, all automation does not need to be a robot. And then a lot of times when we hear automation, we always think of artificial intelligence, right? So machine learning, deep learning, those sorts of keywords. I don't think that's the case either, right? Those are things that make automation easier, but they aren't required to have automation. So what does automation look like? Well, this is kind of a joke in the upper left-hand corner, but, automation doesn't need to be anthropomorphic, right? It doesn't need to look like a human. It doesn't need to be able to do human-like things. On the bottom left, we have an industrial robot, which, kind of is the next step that people may be familiar with. But, even as something as simple as a Roomba, or, other types of AGVs, or even a self-driving car, that's automation, right? That's also, in some cases that could be robot, it could be artificial intelligence, but they all kind of fall under this general umbrella of automation. But it's not just hardware. So I really like examples from kind of the software cloud space, where there's a ton of automation just in developing software, right? That have allowed people to really move faster, to do some really fascinating things. So if you look at CI/CD, infrastructure automation, container orchestration, even things like automatic generation of kind of REST APIs. I think the software space has really led the way in terms of automation, and I think really looking at that going forward is going to be super helpful for all industries, right? Drawing parallels there. So what can automation do? Again, kind of setting context. Automation is really good at certain things, right? So on the top left, we have a pick and place machine for automatic PCB assembly, right? So again, in this case, we're removing, the kind of non-cognitive, repetitive work that a human might have to do. I don't know if anyone's ever assembled a PCB. There's not much to it, but it takes a long time for a human to do. And this robot can do it, exponentially faster than a human. In the bottom right, we have a graphical depiction of what a self-driving car is doing. right? So this is from Mobileye, which is kind of a leading company out of Israel, developing these systems to help control self-driving vehicles. So you can see, I mean, humans can drive better than self-driving cars still, but just the sheer amount of kind of AI and intelligence and automation in the software is really fascinating. And in the top right, this is kind of a joke, but it's the Guinness Book of World Records for solving a Rubik's Cube, right? So this machine is able to kind of faster than a human ever could, solve the Rubik's Cube. So with that being said, we have some good examples of what automation is really good at. Here are some kind of examples, just demonstrating, that we aren't all the way there yet, right? The world is pretty far from being completely automated. On the left, we have videos from, I think it's called Atlas now. It used to be called Petman. This is basically the robot that bipedal robot that Boston Dynamics has developed to study human walking. And in the top left, we have 5 years ago, the DARPA Robotics Challenge, basically these kind of fantastic failures. Now, granted, that is 5 years ago. You can see kind of on the bottom, it's much better now. But really, I just want to show it's still extremely far from what a human can do. On the top right, we have an example of a very dexterous task that a human is doing, counting cash incredibly quickly. And then on the bottom right, we have a robot which is doing something similar, right? So this is a cutting-edge pick-and-place robot from Osaro. And even though it can do it in 5 seconds, and I think these are, can be found in factories all over the world, it's still nowhere near kind of the performance, the flexibility, the dexterity of the human, right? So all of this, again, just to set context, we have a long ways to go in the world of automation. So why are we talking about this? I think people have put a lot of good numbers to this, today and this week, I'm sure. I don't want to overstate anything because, again, I'm not from the space, but I think that, construction is really difficult, and I just think it's a little bit behind on automation. Some people I really trust, I was unable to find direct access to these numbers, but some people I really trust said that, there's 2 industries that haven't really seen a productivity increase in the last 50 to 60 years, right? It's hunting and it's construction. And so I think a lot of that has to do with, kind of a lack of automation, the difficulty with automating things. And so I think, looking at other industries and how they may be automating their, problematic pieces could be very, very interesting for this space. And in the bottom right, we just have kind of a comparison of, the growth in manufacturing versus construction. And manufacturing is certainly one of the fields today that's benefiting specifically from industrial automation. So when we start to think about automation, I think a lot of people think it's cool, right? There's robots in movies. There's even sort of this automated robotic bar in Las Vegas now, where all of the drinks are kind of served directly without any human interaction. But when push comes to shove, I think a lot of people still mistrust automation, right? And I think there's misconceptions about what it can mean to people in the workforce, what it can possibly mean kind of just for your day-to-day life. And so I want to talk a little bit about kind of why some of those misconceptions, what they are and why they aren't true, right? So one is that automation is expensive. So I think this typically comes from the typical depiction of automation in an auto factory, or from really, big failures, right? Where companies like Apple or Boeing or Tesla took really large chances on unproven technology and it failed, right? And in those cases, automation looks very expensive, right? There's little to no return on investment. The machines cost lots of money up front. And it's hard to get over that, I think. But the reality of this, the reality of it is that automation isn't expensive when it's mature, when it makes sense, and kind of when it has the right return on investment for your business. So on the left-hand side, we have an example of 3D printing, right? So 3D printing's been around for a pretty long time now, And it used to be kind of a sideshow, right? It was really interesting. It allowed you to do things you couldn't do with typical manufacturing processes. But a lot of times it just wasn't practical. It cost too much money. It wasn't strong enough. You had to 3D print something 5 times in order to get one good piece. It wasn't consistent. That's no longer the case, right? You can get a 3D printer for less than $1,000 and consistently print quality parts in your house, right? For fractions of the cost that it would take you to have them to get them machined or injection molded or something like that. On the far right, we have an example from the kind of pure software space, right? So it used to be very expensive, to build a website. 30 or 40 years ago, it was also very difficult, right? Today, it's incredibly easy. I mean, give me 20 minutes, I can have a full CI/CD pipeline going through GitHub and GCP or AWS, and a website running, albeit a very simple website that probably doesn't cost me any money, right? Because these services are so mature that they give away some amount of resources for free, right? So there was a point in time when this type of automation and these types of things were incredibly expensive. It didn't make sense for certain businesses, right? That's no longer the case. And on the bottom right, I think this is kind of a current example of automation, which is still a little too expensive, right? But you can actually in real time see the cost coming down, right? So Tesla every year is releasing less and less expensive vehicles with self-driving capability, right? So these are essentially automated transportation devices where we can see every several years the price dramatically drops. And I think at some point this is still much too expensive for most people, but at some point this is going to be automation that makes sense for everyone. So another misconception is that automation eliminates jobs, right? In general, this just isn't true. I think there's, I'm sure a lot of people have seen, various versions of these charts, right? So these are all taken from different sources, but the basic idea is that yes, automation does eliminate certain jobs, right? But in reality, it ends up creating more jobs than it takes away typically, right? And the only thing really to be scared about right here is not the loss of jobs, but rather the need to reskill the labor force in order for the people whose jobs are essentially moved, right, from a more non-cognitive routine work to more cognitive non-routine work. We need to make sure that those individuals are reskilled in such a way that they take advantage kind of these higher paying, more transferable skills. And then finally, another misconception, I think a lot of people think at the end of the day that automation just doesn't work. So here, I just think in general that's not true. Again, we have kind of all these sexy failures in different industries, right, where millions, if not billions of dollars are spent on trying to automate something very difficult with non-mature technology. But the reality of this situation is that, when it fits, it works, right? So on the left, kind of a selfless plug for my current company. This is a security device being assembled by Bright Machines robotic cells. On the top right, we have Icon, which some of you may be familiar with. So this is a company that actually builds robots that 3D print homes. And then on the bottom, this is actually a lab at Google, which is using machine learning to do picking, kind of arbitrary picking of items in a bin. And even though this isn't fully mature technology, these robots are running, 24/7, learning how to pick things all day long, right? And they succeed much more frequently than they fail. Okay, so we've addressed some of the issues or some of the misconceptions there may be around automation. So now I want to talk a little bit about why we may need automation, right? Because I think this is really the crux of the matter. It's not that automation is cool or that automation helps make people more money. The reality of the situation, I think, is that we as a society need automation. So automation can help with decentralization, right? So why is decentralization important? Well, one kind of negative example of this is with PPE, right? So when COVID first broke out, basically all the PPE in the world was being manufactured in China. China shut down for a while, and we weren't able to get PPE. right? And so this is an illustration of why it is important, to decentralize manufacturing, to manufacture closer to the consumer. And a lot of times in order to be able to do that, you need to automate the process so there's a return on investment, for the people who are doing the manufacturing. Here, kind of in the upper left-hand corner, I found this video. I assume this is a relatively new factory line where they have actually, invested the capital to automate face mask manufacturing, right? And so this is something that where, you could actually transfer these lines around the world closer to the consumer, so that, if one factory has to shut down, they don't all have to shut down, right? And you don't disrupt the global supply chain. Another reason that I think, decentralization is really interesting and important is the idea of kind of, not limiting yourself to a particular workforce. So a great example of this, I don't know how many of you are familiar with GitLab. It's a competitor with GitHub, so it's a source code management software, cloud-based software. They are 100% remote, and they always have been, right? So there's a really interesting Harvard Business Review white paper on this. But they are actually able, kind of through software automation, right, to be 100% remote, and to be a really impressive company that's able to function really well that way, right? And I think again, something that was emphasized by COVID is this idea that maybe it's not a good thing for us all to be in the same place, right? Certainly from a business perspective, being able to reach talent across the globe and make use of that is a really good thing, right? So I think automation really helps with decentralization. Automation can lead to less waste. So I've heard some talk about generative design. Here I have an example from outside the AEC space. On the left, this was from a white paper by Autodesk, where they worked with Airbus to use generative design on a bulkhead, right? So the bulkhead was relatively light to begin with, right? A little over 100 pounds. But they were, through generative design, able to actually reduce the weight by almost 50%. And, just for one aircraft, right, replacing those bulkheads with this 50% lighter version, they actually would be able to cut CO2 emissions of that single airplane by 150 metric tons per year, right? Not only, right, do they kind of like save on the fuel, but it also uses 95% less raw material, right? So that's just a really simple example of how kind of automation, again, eliminating the repetitive, non-cognitive tasks, allowing the human to input constraints, right, make the cost-benefit analysis for the part, and then letting the automated software actually do the work. It's just a really good example of how that has, really like fascinating impact. And then on the right, we have, kind of a machine learning inspection software from Instrumental. And this software was deployed extremely quickly, and in a matter of weeks was able to identify, 10% a 10% defect rate on a beta line that the engineers in the factory were not able to identify, right? So if they had gone straight to production, right, 10% of all product coming off this line would have been defective, but they were able to identify that and fix that, using inspection automation. And then finally, why is automation important? I think automation is the only way we can keep up with demand, right? So every single day, hundreds of people join the middle class, and all of those people need their devices. They need their refrigerators. They need their cell phones. And we're not going to be able to make all those things by hand, right? And so using automation, as the world continues to grow, we'll be able to manufacture things at the rate required for all of the people to live, safely and comfortably and healthy. And with that, I'll leave you with just the message that, automation is incredibly important. I think it applies to like all spaces. And I think hopefully the AEC space can take lessons learned from manufacturing and software and use them to like help improve kind of the speed at which they adopt automation. So thanks again, Shadow, for having me. And we've got a fair amount of time left. So if anybody has any questions. I'd be happy to answer them.
Thanks, Barrett. So yeah, since we have some time left and this is the last session of this track, if anyone has any questions, please feel free to pop those into the Q&A. And then I know sometimes it takes a minute for people to type questions. So Barrett, can you remind everyone how to get in touch with you in case they have?
Yeah, for sure. So I'm on Slack, so please feel free to just type questions in the Slack. I'd be happy to answer them there. Or if you want to email me, my email is barrettclark87@gmail.com.
All right, it looks like we've got one question. And it says, culturally, how can the AEC industry better attract technical talent that they don't know the industry? We aren't cool like Tesla. Yeah,
so I think Brian kind of made this point in his talk. I didn't like 100% agree with it. So, you know, like I think his point was that, you know, Tesla comes in and they kind of like make cars sexy again. I think, you know, the fact of the matter is that automotive always got the best automotive engineers, right? And I think like what Tesla really did is they blended technologies, right? So you no longer just had like the car nerds. I don't really like the word nerd, but you know, you no longer had just the car nerds who wanted to go work for a car company, right? You had all the best car nerds, but then you also had all the best, you know, self-driving car nerds and all the best computer vision engineer nerds and all the best electrical engineering nerds. And, you know, like because they were disrupting multiple industries at the same time, you know, they were attracting, you know, more diversity of talent, right? And we know that's important. We know diversity kind of in all aspects is super important to be able to disrupt industries. So I think, you know, I think kind of this, I don't know, like, I guess I would call it kind of a cross-training approach, right? I think thinking about how AEC disrupts, not just as like using better and smarter AEC people, right? But how do we, you know, attract people from other industries, right, to come here? You know, I think that's as much about kind of messaging and opportunity as it is anything else, right? Yeah, I hate it, but sorry, I'll read the question. Everyone thinks Silicon Valley is the center of innovation. Does that apply to robotics? If you had to build a robotics company, where would you start it? Yeah, unfortunately, I think it does. If you look at like even industrial automation companies have centers in Silicon Valley, or, you know, in the Bay Area, let's say. You know, I know Amazon's like manufacturing R&D centers in the Bay Area. You know, I think at the end of the day, like a lot of the top talent lives there. With that being said, I mean, I think as long as you're willing to allow remote work in this day and age, I think you can kind of start it anywhere. I think, you know, if you're gonna build industrial robots, there's actually an argument that you want to be in a city where it's less expensive to live, right? And the big reason for that is you're gonna need a lot of space, right? And so I think, you know, if you live in a city like Austin, where maybe the cost of living is still relatively inexpensive, and you can get a big warehouse where, you know, your brilliant engineers can still live downtown and get to work in a timely fashion, I think that's super helpful. At the end of the day, right, like the best and the brightest probably are in the Bay Area. But you know, I think as long as you're willing to get away with remote work, you can get around that. Yeah, I struggle. I want to say yes. Sorry, again, I'll read the question. Is it possible to run a hardware robotics company with a remote team? I think so, right? I think specifically, if you're not as focused on the hardware, right? and you're more, and, you know, like I think one of the things that we're trying to do at Bright Machines is, you know, democratize hardware, right? We don't want to care what hardware you're working on, right? We just want to kind of build a platform that your hardware runs on. So if you're taking that approach, right, then I think, you know, certainly it's possible. I think inevitably you'll end up with kind of these like centers of excellence, right? Where people will have to travel there in order to be able to, like, you know, test their prototype, or, you know, test their code or collect data. You know, I like to think it is, right? But I think it requires a certain amount of creative thinking that, you know, like the old school robotics industry doesn't have yet. So I think we'll get there. I think it is possible. It's certainly not as easy as it is with software, but I think it is possible. Is it true that KP was the best boss you ever had? That came from KP. But yes, I think KP is certainly one of the best bosses I've ever had. And I can say undoubtedly he was the best mentor I've had up until this point.
All right. I don't see any other questions coming in, but as Barry mentioned, he mentioned how to reach him. There's also some conversations happening in the Slack channel, so please feel free to head over there. This is the last session for the operate track, but there's still sessions happening in the design and build track, so please feel free to head over to those tracks. And thank you again, Barry. Or Barry. Yeah. So sorry, I don't know why I just called you Barry.
Oh, either one's fine. Yeah, thanks a lot for having me. I really enjoyed it.